I'll tell you about some of the research that's been done on food addiction to show you that this is real. Nicole Avena, who is a prolific researcher in the food addiction field, used animal models, lab rats, to study the effect of sucrose on behaviour, and she published a paper in 2008 where she described a study where she gave lab rats a limited access to a 10% sugar solution. And what she meant by limited access was that in a 24-hour period, the rats were given 12 hours where they could have access to their normal rat chow as well as this 10% solution. So they had that ad libitum. And what they noticed was that over time, over the course of 21 days, the rats would consume more and more of the sugar solution. They would go to the pipette, they would self-administer this sugar solution. They regarded that as an addiction, but it didn't happen to rats who were only given presentation of the sugar solution occasionally. So remember I said to you about the novelty effect? So what they were doing to confirm what was going on was that the researchers inserted a probe into the rat's brain to measure extracellular dopamine. They anaesthetised the rat, shaved the top of their head, put a probe in, and the probe, and they use what's called microdialysis, and they draw off interstitial fluid to measure extracellular dopamine. And so the rat sort of walks around with this sort of funny looking probe out of their head, and when they want to measure interstitial fluid, they'll hook it up to very fine tubes to measure that, so that they can tell how much dopamine is being released when the rat is eating either sugar or rat chow. And when they administered an opiate agonist to these rats, in which this case was naloxone, and that actually blocks the dopamine receptor, the rats experienced withdrawal effects. They showed the behavioural attributes of a rat that was in distress. And they were also able, through this probe, through this microdialysis, to measure a substance called acetylcholine, which is released when a person or a rat goes through withdrawal effects. So Nicole Avena and her colleagues have done further studies on rats to see what they do when they eat food like junk food and what happens to them. And so what she did was she had a group of rats, and she randomised them to two groups, and she placed one group on a cafeteria-style diet, which was basically a junk food diet. So any kind of food that you went into a service station, and any food in a service station is basically junk food. And so that's what the rats were given. They weren't given any rat chow, just this cafeteria-style diet, and the purpose was to induce obesity. Oh, I should mention that some of the junk food was higher in carbohydrate and some of it was higher in fat, but the rats actually preferred the higher carbohydrate food, hence the weight gain. And the second group of rats were fed their standard rat chow and they maintained their normal weight. The obese rats developed brain changes. And so, of course, they had the probe in their brain to measure extracellular dopamine. And what was funny was they actually showed lower extracellular dopamine. But the obese rats only released dopamine in response to the cafeteria-style diet, but not the standard rat chow. And this is thought to be one of the reasons why some people develop addictions, is because they're not releasing as much dopamine as other people who aren't prone to addiction. And there's a whole lot of research about why that might happen. And frequently you see that in people who have experienced early childhood trauma, that they are at higher risk for developing addiction later in life. And it's thought that they've undergone brain changes, maybe through epigenetics, so that they don't release as much dopamine. So what they found, the researchers concluded, was that there was a link between food preference and central dopamine, and maybe that explains why some people will go to certain foods because they are comforting when they're distressed. So they concluded also that a dopamine deficit is implicated in overeating and obesity. So there's been other findings from other animal studies, and there's been overlap seen in animals between sugar and drugs of abuse. So animals have shown similar behaviours for drugs of abuse. And, remember, self-administered binging, tolerance and withdrawal, as with sugar. So they showed the same chemical changes, that increase in dopamine for sucrose as for drugs of abuse. I should mention sucrose is table sugar, so it's 50% glucose, 50% fructose. You often see in the media, you'll see headlines like, sugar 8 times more addictive than cocaine. There's actually no evidence for that. The different amounts of dopamine released are actually dependent on what the drug is, or what the dose was, or how much sucrose was in the solution. So you can't actually say that sugar is X number of times more addictive than another drug, or vice versa. So what they've found from the research is that highly palatable, high sugar foods hijack the brain reward system so that they may ultra reward and lead to overconsumption. And in another study, rats that were fed this, they're actually fed M&Ms. And what they did was they would cross an electrified barrier to get to the M&Ms. And they've also shown that the greater the variety of food, regardless of hunger, the more is eaten. And you see that in a buffet-style presentation of food, that people will eat more in that situation. And it's probably because of the novelty effect and the increase in dopamine. And so it's also been shown in addiction studies that there is what's called a cross-sensitisation, so that if a person is dependent on one substance, they're more likely to develop a dependence on another substance. And you frequently see, nicotine and alcohol going together. I haven't come across too many alcoholics that aren't dependent on nicotine as well. And when alcoholics abstain from alcohol, they often pick up another substance, and sugar is a frequent substance that they will substitute for alcohol. So it's proposed that, is sugar a gateway drug?